We're going to look now at how you can use your knowledge of transformations to graph some kinds of rational functions. We know that rational functions can be nasty graphs to produce by hand because they involve features that are unpleasant, like horizontal and vertical asymptotes, gaps in the graph, a lot of nasty little things. So transformations can help us graph some kinds of rational functions. So I'm starting off with this basic rational function, y equals 2 over x, and you can think of that, if you want, as the graph 1 over x, which has been vertically stretched by a factor of 2. All right? So there's a transformation of 1 over x to get 2 over x. All right? But I'm not going to think of it that way. I'm going to simply start with 2 over x because that's an easy enough graph to start with on its own. So I'm going to start with a couple of accuracy points. I know that x can't be 0, not applicable. If x is 2, y is 1. If x is 1, y is 2. Here's a couple more. And I can plot those points. And because I know how the asymptotes work on this graph, and etc., etc., I know that the graph looks like that. And let me just dot in my asymptotes. Now, what I'm going to do is I'm going to use this basic graph to graph this more complex function. And you'll notice that all I've done to go from this function to this one is that I've replaced x with x minus 3, and I've replaced y with y minus 1, and moved the 1 over to the other side. In other words, this graph is a transformation of 2 over x, 3 units horizontally, a translation 3 units horizontally, and 1 unit upwards. And so because of that, all I need to do is take the graph that I produced up here and slide it 3 units to the right. Now I get to do it the fun way, and 1 unit up. And I'm done. And I can see that if I were asked for my vertical asymptote, I can see that my vertical asymptote equation is x equals 3, which, remember, relates to the non-permissible value. And my horizontal asymptote relates to y equals 1. So I was able to graph this more complex rational function only because it was set up in a nice way. It was set up as a transformation of this graph through translations. And if you can set your rational functions up that way, then that's a handy way to graph without having to use a calculator. So of course you might say, well, yeah, but this function was set up in a rather unique way so that I could recognize what the transformations were. What if that wasn't the case? What if I had a function more like this? Now this equation is not set up in the nice transformed form that our last equation was. But the question is, could we turn this rational function into the form a number divided by x, 2 divided by x is where we started with the last one, and then apply our transformations? Could we turn the equation of this into something like this? Because if we could, using transformations to graph can make graphing this rational function perhaps a little bit easier. All right, the answer is, with this particular equation, you can do this. So I'm going to demonstrate how this works. So I'm going to start off with this equation. And the first thing I'm going to notice here is that if I were to factor the numerator, the x plus 1 and the x minus 1 would not cancel out. All right? So the key to making this work, the key to being able to turn it into this form, is we would want to have a minus 1 there if we factored it out. All right, so the way I'm going to do that, let's take some of this away, is I'm going to rewrite my numerator as 2x minus 2 plus 4, because the minus 2 plus 4 is still 2. All right? And the reason I'm doing that is because if I factor out 2 here, I'm going to get x minus 1, which is going to cancel in the denominator later. But we'll get to that in a moment. Let's just start with this step. And then I'm going to break my equation into 2 parts. The part that's going to cancel with the x minus 1 and the part that is not going to cancel. And that's going to, okay, I'm going to factor now. And these are going to cancel out. And you'll notice that I've now got my f of x down to 4 over x minus 1 plus 2. In other words, I've turned my equation into this transformed form. If I think of starting with a basic function of a over x, 4 over x, and then x replaced by x minus 1 means that we're going to translate the graph 1 unit to the right, and the 2 here is going to be a translation 2 units up, I will have graphed the original function. Alright, so we're going to graph this easy function, this basic function, because we know it. We know that it has vertical asymptotes at x and y equals 0. We can quickly get some accuracy points. If x is 4, y is 1. If x is 2, y is 2. If x is 4, y is 1. So the graph's going like so. And we get the same points when x is negative, except the y's are negative. And now I can graph this more complex function by taking my 4 over x and translating it 1 to the right and 2 units up. And I can now see that my horizontal asymptote is y equals 2, my vertical is x equals 1. Alright, so I was able to change the form of this rational function to transformation form to make it easier to graph. But this isn't always possible. But when it is, it's a handy technique to use in graphing rational functions.